everybody. Welcome back. This is section, or unit. It's a unit. We're beginning a new unit today on 3.1. It's on polynomials. And really all polynomials is basically multiple, either quadratics or linear, like lines multiplied together. So I have polynomials, polyfunctions, polyquadratics. So many together, okay? So many factors multiplied together. So we're going to look how to classify polynomials by degree and number of terms today, and also how to determine the end behavior. So what each end of the graph is doing, okay? So first of all, we're going to start by classifying the polynomials. So first of all, a definition. A polynomial is a monomial. Let me get some signs here going here. It's either going to be a monomial, which is a single term, or the sum or difference of one or more monomial called terms. So it could be multiple terms or just one term. The degree of a term with one variable is the exponent of that variable. Okay, the degree of a term with one variable is the exponent of that variable. Okay, a standard form of a polynomial always starts with the biggest degree first, and then kind of works its way down. So it shows any like terms combined. So you always get them combined together in like terms, and then we're going to put the highest degree first, and then descending in numerical order. So on this guy right here, my standard form for here was first of all, look and always see we have combined like terms, which we have. Then I'm going to put my highest degree first, so 2x cubed. And then my next one's going to be minus 4x, and always keep your signs with it. And then my last term will be my 9. This is my constant term. Here it's always referred to as my constant term. Okay. This is my cubic term because it has a cubic term, right? This is my linear term because it only has a 1 degree, okay? And we have 3 terms here altogether. We have a monomial here, a monomial, and a monomial. So we have 3 monomials added together, making up a trinomial. Okay, so we're going to learn how to classify these as a cubic trinomial because it has a highest degree of a 3, okay? So we're going to look at this table here. If it has a degree of 0, so it just doesn't have any variables with it, it's just a constant. Okay, so first let's look at the polynomial examples. A degree of 1 is a linear function. A degree of 2 is quadratic. We just studied all that last unit. A degree of 3 is going to be cubic. 4 is quartic, and 5 is quintic. Beyond that, if it's like 6, we just call it a 6th degree polynomial. Okay, if it's 7 and so on and so forth. So nth degree, whatever it's 9th degree, 10th degree. So beyond 5, it doesn't have a special name for it. Okay. Number of terms, of course, is just how many terms we have in it. So this has 1 term, is a monomial. This has 2 terms, so that would be a binomial. This has 1 term again, so another monomial. This one has 3 terms, so that's a trinomial. So this is 2 terms, it's a binomial, okay? So this first term here would just be a monomial. This would be a linear binomial, we call this, okay? So it's classified by degree and number of terms. This one right here would be a quadratic monomial, okay? This one right here would be a cubic trinomial. This guy here would be a quartic, because it's a power of 4, binomial, because there's 2 terms. So by degree and number of terms. This one is going to be quintic, because my highest power is 5, and then my number of terms is 4, so it's a quintic polynomial of 4 terms, okay? Because we don't have a special name for the beyond a trinomial, we just start calling it polynomial of 5 terms or 4 terms and so forth, okay? So you might want to write that table down or take a picture and make sure you have reference to that. Okay, so what is each polynomial in standard form first, and what are the leading coefficient, the degree, and number of terms? So let's put this in standard form, make sure we have everything combined in like terms, which we do. Now I'm going to put it in standard form, so my highest degree first, so 5x cubed minus 3x to the 4th power plus 2x plus 6. Okay, so first of all, my leading coefficient is going to be, write this out first. Leading coefficient is -5. It's a very first term. You have to have it in standard form first to be able to identify that, right? Okay. What is my degree? So my degree of my polynomial is my highest degree once I get it in standard form. So my highest degree is 3. So it's a degree of 3. Okay, and the number of terms for each right here. So we have 4 terms, number of terms. We have 4. And if I'm going to classify this, right, it's a third degree. So I'm going to call it cubic, not third degree, it's a cubic, and then we have 4 terms. So it's a polynomial of 4 terms. That's how it's classified. Okay. All right, so let's take a look up here again. Next one. So you might want to try this. Just pause it and put it in standard form, and then identify the leading coefficient, the degree, number of terms, and go ahead and classify it. I'm going to add that on there. Okay, because we're going to be classifying these guys. Okay. All right, so first we're going to put it in standard form. Make sure we have all of our terms combined, which we do. They're all like terms of combined. Then I'll put it in standard form, which is going to be our highest degree, which is 6. So 2x to the 6th power. And then plus 5x to the 5th power. Minus 3x to the 4th. And then plus 4x cubed. Minus 8x. Okay. Leading coefficient is 2. My leading coefficient. I'm going to take some shortcuts here if that's okay. My highest degree is 6. That's my degree. Okay. My number of terms, I got to get a different color here. My number of terms is 1, 2, 3, 4, 5. So 5. And then if I'm going to classify it, this is going to be a 6th degree. So we don't have a special name for 6th degree. So we're just going to say a 6th degree. And then we have a polynomial of 5 terms. And that is it. Okay, so that's classifying by degree and number of terms. Okay, you're going to see that quite often. Okay, so now we're going to get on and what do our graphs look like on these guys? Okay, so you might want to make sure you take really good notes here. Okay, so how did the sign of the leading coefficient and the degree? So I need you to really pay attention to this because we're always going to look at the leading coefficient and the degree of the polynomial. Those are my 2 keys that are going to tell me what my ends or my right and left side of my graphs are doing. So notice here that each of my ends have odd degree powers. Okay, I guess I should have put that in green because I just circle that on the top. So my odd degree polynomial. So you look right here, f of x, my orange one is just a degree of 1. My orange one is just a straight line, right? Degree of 1. My blue function has a degree of 3. My green function has a degree of 5. So these are all what they call odd functions. Okay, so these are all odd functions. If they ask you if it's an odd or even function, that's how you tell if it has a highest power of an odd or even. Okay, and I want you to notice what the ends are doing. Okay, they're going in opposite directions. So if the degree is odd, my ends are going to be doing opposite things. Okay, the next thing we're going to look at is our leading coefficient. So remember, the first thing we always look at, number 1, is going to be my degree. That's going to tell me what my ends are doing. Are they going opposite or the same direction? Number 2, I'm going to be looking at the leading coefficient. Okay. And once I look at the leading coefficient, that's going to tell me kind of what's going on with my ends. So if my positive leading coefficient right here, if it's positive, it's always going to be going up on the right-hand side, just like a line. Okay, if you think about your slope of a line is going to kind of go positive slope up from left to right. So if it's a positive leading coefficient, I'm going up on the right-hand side, which means if it's odd, it's going to be going opposite on the other side. So it'll be going down on the left-hand side. Okay. And over here, notice that I have an odd degree, a negative leading coefficient. So if it's a negative leading coefficient, we're going to be decreasing from left to right on the right-hand side, going down. And then that means since it's odd degree, we'll be doing the opposite thing on the other side. It'll be going up on the left-hand side, okay, or towards positive infinity as x goes to negative infinity. So just kind of think about it as going up, up or down initially. You can think about up or down on left and right-hand side. But what we're going to look at next is how do we actually write that properly, okay? So if you look at my end behavior, if we have when we look back over here, sorry about that, I'm going to go back. So you look back over here with odd degree, positive leading coefficient, right? Okay, so we have an odd function and positive leading coefficient, right? we have as x goes to infinity, so as we move right on the graph, our y value is going to also be going to positive infinity. It's going to be going up. So x values go positive, my y values are going positive also. Okay, this goes back to kind of our interval things. On the left-hand side, as our x values move to negative infinity over here, as x goes to negative infinity, my y values are going to also negative infinity. Okay, and that's how that looks. Over here, remember over here we had also an odd function because they're going opposite directions, but this time we had a negative leading coefficient. So the negative leading coefficient, as x goes to positive infinity, my y values are actually going to go to negative infinity. It's going to go down to negative infinity. Okay, and then over here on the other hand, on this side, as my x goes to negative infinity, my y is going to go to positive infinity. Okay, and so that's how you tell your end behaviors. You first look at your degree. Are the ends doing the same thing or the opposite thing? And then your end behavior. And sometimes I actually look at the coefficient first to see if my right hand side is going up and down, and then I look at the degree to see if they're doing the same thing or the opposite thing. Okay. Okay, so now let's look at what happens if we have an even degree. So notice, on our odd degree, we're going opposite directions, right? Our ends. On even degrees, notice they're going the same directions. They kind of have the characteristics of a parabola, except that what happens is we end up having some bumps. We'll have bumps in the middle, or it'll go up and down, or have these little curves in there. But the ends are going in the same direction, okay? So once again, we have an even degree here, 2, 4, 6. We have a positive leading coefficient here and a negative here. So remember, the leading coefficient tells us if it's positive, we're going up on the right-hand side. If it's an even degree, we're doing the same thing, okay? Negative leading coefficient tells us we're going down on the right-hand side. Even degree says we're doing the same thing, so they're both going down, okay? And so this is what's called an even function, right? That says it's a positive or even polynomial. This is an even polynomial, okay? Because my highest degree is even, okay? And those are all each of those graphs. So let's take a look at how we write the end behavior on these again as well. Okay, so each of these functions, it doesn't matter which one, but each one of these functions up here as x goes to infinity, my y goes to positive infinity also. And over here as x goes to negative infinity, my y goes to positive infinity also. They do the same thing. So notice my y's are doing the same thing. My function is doing the same thing. Okay. Over here as x goes to the positive side of the graph, positive infinity, my y goes down to negative infinity. It's going down. Over here on the other side as x goes to the negative infinity side of the graph, my y is going to go the same direction over here to negative infinity also. It's going to go down. Okay? And that's how you determine end behavior. Okay? So let's take a look at this. Use the leading coefficient and degree of polynomial function to determine end behavior of the graph. And I think I told you at the beginning, I always look at the degree first. I take that back. I actually always look at the leading coefficient first. Okay? So always look at the leading coefficient first. Then I look at the degree to see if the other side is doing the same thing or the opposite thing. Okay? So leading coefficient will tell us, is it going right? Here, I'm going to actually, let's do this. I'm going to give you a little bit of a hint even. Okay? So I'm going to look at leading coefficient. If it's positive, oh, I need a pen. If it's positive, it's going to be going up on the right-hand side. If it's negative, it's going to be going down on the right-hand side. On the right-hand side, okay? Then I'm going to be looking at the degree. Okay? If the degree is odd, okay, that means that my ends are doing opposite things. Ends are opposite. If it's even, my ends are the same. Okay? So that's kind of a little cheat sheet for you, okay? So looking over here, I'm going to look at my leading coefficient first. It's a positive, right? So my right end is going up. So I kind of like to make a little diagram like this. Then I look at my degree is even. So that means my other end is doing the exact same thing. Okay? So remember, this tells us, my leading coefficient tells us what our right side is doing. Okay? And then the other side will tell us what our the rest of it is doing. Okay, my other side is doing the same thing or opposite thing here. Then I can write it out. Okay, so now I can say as x goes to positive infinity, so on the right hand side here, my y value will be going to positive infinity also. Over here, as x goes to negative infinity, I know that my y was also going to be going to positive infinity, just like this side over here. Okay, so that's how you write it out mathematically. This is how you kind of sketch it out so you can kind of know what's going on. And we're going to talk later about what happens everything in here with, bumpy graphs or whatever, but we just want to find our n's first. Then we'll talk about how do we find our zeros a little bit later. Okay. All right, so let's look at the next one. Our leading coefficient this time is negative, right? So that means on the right-hand side, it's going to go down. It's dropping down. Then we're going to go ahead and look at our power. It's an odd, which means my opposite side is going to be doing the opposite thing. Odd stands for opposite, okay? So if I want to go ahead and write that out, I can say now x as it approaches infinity, as it moves to the right, my y is going to approach negative infinity. It's going to go down, down, down. Conversely, over here, as x moves to the left to negative infinity, my y value is going to go up, 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 up. It's going to approach infinity. Okay? And that's what my n's are doing. Okay, so this is kind of, again, graphically kind of representing what's happening. And this is sort of how to represent it algebraically here. You need to know both. Okay? All right. So that is what you have. See my little joke here. What's his problem? Oh, don't mind him. He's a little odd. See, he's going in the opposite direction there. It's funny. Okay. All right. So you have an assignment 3.1 in Google Classroom. It's a Google Slides activity. So have fun with that. And then I will catch you all in our next Zoom. Thanks a bunch. Have a good night.